energy sector. This is a joint project with my PhD advisor, Professor Farah, and we are from the Stevens Institute of Technology, New Jersey, USA. The brief outline will be, we'll be discussing the research questions, our methodology, research, and the model. As all of you know, by green technology, we mean the renewable energy sector, basically dealing with the hydroelectric power, wind energy, solar, biomass, geothermal. The research question that I want to answer today is, when a patent from these technologies receive a future citation, it could be a citation from within my own technology area, which I call the in-class citation. It could be a citation from an outside area, which I call the out-class citation. I want to make sure whether any of these in-class or out-class are a better innovator, driver of innovation than the other one, and whether there is any interplay between these two. So let's proceed. I collected the data from the United States Patent and Trademark Office, and you can see the year from 1976 to 2008, and these are the 5 energy types that I considered: the solar, water, wind, bio, and geothermal, with these number of patents. The initial analysis showed a steep peak with the solar energy. You can see a little bit of peak in the 1980s, which is probably due to the oil embargo or the Iranian Revolution, during which US started focusing more on the green technology area. And then later on, from 2000 onwards, we see almost all of them developing with solar the most. If you have a question regarding why solar is having such a steep peak, maybe we'll discuss it later. In our methodology, what we did is, after collecting the green energy data, we wrote some Java programs to find the year of grant of the patents and also the future citations. And we categorized those citations as in-class citations, meaning the citations got from my own community, and then the out-class citations, meaning the citations that I got from outside some other community. The analysis is basically like this. In the first column, you see the technology type, followed by the second column that you see here, OP, is the total number of patents got from the USPTO. Third column, you get those patents which received future citations later on. The fourth column will give you the number of in-class citations with their percentage, and then the number of out-class citations with their percentage. One thing that I want to make a note here is, you'll see that in almost all the cases, I should say in all the cases, you'll see that the number of out-class citations is much more than the in-class citations. What happened with this one? This is not displaying properly. Anyway, let's see whether I can do something with this. The Z component that you see right here is the component on the left-hand side. And that's the number of patents, for example, say in the year YI+1, that will probably receive future citations. I want to see whether this can be expressed as component, as some combined components. In our model, what we did is that this ZYI1 is represented as a linear function of the cumulative in-class citations. Basically, this got garbled out. I'm sorry for that. I don't know why this happened. But this one is the cumulative in-class citations for the patents in the previous year. That means YI. And this is a linear function of the cumulative in-class citations for that year. I mean, for the year YI+1. So basically, I'm representing the number of patents produced in a year YI+1 as a linear function of the cumulative in-class citations in the year YI, added with another factor, which is a linear function of the cumulative outclass citations of the previous year yi, which was here and is not now. And then there is a time factor, which is represented by hyit. That's the nth degree polynomial. I'll check whether I can. And then there is a constant factor. Oh no, this is all gone. All gone. Since we considered the time frame 1976 to 2008, and there is a time factor, I considered 1971 as my starting point, that's 0. And then, as I proceed to 1976, 77, and so on, I represented those as 1, 2 to 32 for all the years. And then, this should be a t. I don't know why this has come to I. This is my t, and then I calculate my t square, t cube, and so on. When checking this in my model, I saw that the coefficients of T4 onwards are negligible, and hence we didn't consider them later on. Now, maybe I can explain it better here. This is the regression model when it is fitted to the solar energy data. As you can see here, the blue one is the original data, meaning the number of patterns coming out in a year. These are the years in the x-axis. And in the y-axis, you see the component effects. The estimate that my model calculated is given by the green one. I think that's a star. It is represented as a combined effect of an in-class component of the previous year, an out-class component of the previous year, and also a time component. One thing that I want to point out here is you'll see that the estimate very closely follows the outclass component, meaning that the outclass citations made by patents which are outside my community do play a significant role in my growth and evolution. So we need to pay attention to the outclass citations also. This is the expression, the Z is the number of the patents produced. The X factor that you see over here is the in-class citation, the Y is the outclass. You have a polynomial in T that captures the effect of time, and then a constant. Here you see the Pearson correlation coefficient for the in-class function versus estimated model, and also for the outclass function versus the estimated model. And as you can see here, the second one, that is the outclass function, correlation is much more. Same with wind energy. Here also you see the interplay between the three factors, and here too you will see that the correlation with the outclass components is surpassing that of the in-class component. We come to biomass. Same thing here too, and you can check out the curves, how it looks like. Let's proceed to hydroenergy. It's a little bit tweaked this time, because here you see the in-class components having much more significance than the outclass ones. For the geothermal too, the same thing happens, and I tried to capture the effect of the in-class, outclass component and the time factor, and try to explain it by considering these 5 energy sectors. In the conclusion, I want to say that we tried to do a mixed regression model to quantify the effects of the in-class and the out-class components, and we do believe that future innovations occur as a combined effect of these two. One interesting thing that we want to point out is this, maybe in contrast to our belief and thinking, sometimes outclass citations can play a significant role in the growth and evolution of our technology. So, ladies and gentlemen, if you do receive citations from outside your community, just make sure that you would be sure that you are in a good position, and never ignore that. So, that's it. Thank you.
Thank you for your nice presentations.
Thanks.
Any comments?